Hi everyone, before we get started, I'd like to do a quick audio check. So if you can hear me, please type into the chat window. Looks like everyone on the line can hear me. So before we jump into things, a couple of administrative items. We want to make sure this is a discussion. So we encourage you to ask any and all questions in the chat panel. I'll be keeping track of these for the Q&A session towards the end. Last, if you missed anything, don't worry, we are recording this session and we'll be sure to email this out. Okay, welcome to our webinar all about Snowflake. Today you'll be hearing from myself and one of our data solution engineers, Sean. I will be sharing a bit about our customer chat books and their data journey. Then Sean will dive into the Luma platform and we will end with a quick Q&A. So first, a little bit about chat books and their background on their data struggle. When their director of analytics, James, came to us, he was dealing with data infrastructure stack that was minimal. Reporting was run against production servers and just in data snapshots. And he was tasked with creating a more robust infrastructure that scaled, as well as provided insights so that key stakeholders like marketing could make real business decisions. And really, at the end of the day, they just didn't have the value that they needed to get from their data. As we dove in to the project, we found that they faced three main challenges. They were having issues and wanted to better understand how to manage dynamic schemas, how they were going to handle errors, and how they were going to really transmit data exactly once. How were they going to really ultimately trust their data? So through this project, we implemented the Luma platform to handle their managing their schemas, handling errors, and transmitting their data. Also, we helped them migrate off of Redshift to a more powerful and scalable data warehouse, Snowflake. In the end, by unifying all of their data and combining Alooma and Snowflake, they found seamless integration, simple transformations, and they saw a reduction in their engineering overhead, as well as an increase in their net promoter score and improvements across their marketing organization from efficiency, and they were able to make real-time data decisions and improve their marketing KPIs. But that's just a story. So now I want to ask Sean to take us through a little bit more about Alooma and how we were able to achieve the results that Chatbooks saw. I'm going to hand it over to Sean.
Thank you very much, Tasha. Okay, great. So let's just jump right in here. This is Alooma. This is the main plumbing screen. It's the first thing you'll see when you log into your system. You can take a look here. All the integrations are listed down the left-hand side, and all data flows out of those into the pipeline, where next up they'll encounter is the code engine. And this is the part of Alooma that takes care of dealing with transformations, so basically modifying the data as it goes through our systems. Next up is the mapper, and this is the part that takes care of inferring schema changes and is responsible for mapping input data types to the appropriate output data types. And lastly here on the right-hand side, we have the Snowflake connector itself. So I'll just jump in here to a flow and show you what it's like, what the general process is for adding a new integration. So we'll go up to the top left here and click Add New Input. And these are the list of integrations that are natively supported. I'm going to search here for Postgres, and you can see that our search as a result has returned this. And then I click it, and the first thing it always asks me to do, it doesn't matter which integration it is give it a label. So I'll just call it Test. And now, when I hit next, we've hit into our pretty much one-stop configuration page for our Postgres replication. So we got some pretty standard stuff here to fill out, basically some configuration in order for us to log into your system. So hostname, port, username, password, pretty standard stuff. And then we offer the options here, connection as well via SSH if that's a requirement. So sometimes if there's hosted Postgres, you might need this option. So we also support both standard tunneling and reverse tunneling. And then right after that, we get into the meat of it, which is the actual replication methods themselves. So we support 3 different types: full dump, incremental, and log replication. Full dump is just obviously your table snapshots. Incremental is in those cases we have tables where you have an updated at column indicator and you're doing that periodically. And lastly, then we support as well log replication, which is using the Postgres wall, where we'll read the log statements and replicate those changes downwind into your Snowflake warehouse. You also have a little option here as well to dump an initial snapshot. So this is for initial backfills for historical sync. And something, and again, you'll notice throughout all of our integrations, it doesn't matter if it's a relational database or a SaaS service or files, you'll always have the option of selecting the mapping mode. By default, it's automatically set to 1 click, which means that if the schema changes, if a new column gets added, we'll automatically update our mapper and the underlying Snowflake table to match. And that's pretty much all that's required on our side of things, or on the input side of things, to kick this off. Once I've set all of this up and I click finish, this will push me back to the plumbing screen where you'll start to see this source being set up and start ingesting data. And that's pretty much all we need for the Postgres side of things. Once that's done, as I say, you'll come back here and you'll see it being added to the plumbing screen. Next up is the mapper. And you can think of the mapper, again, at a high level, as just a part of Alooma that takes care of managing your schemas and any changes that happen in those. And also it's responsible, as we said, for mapping data types. So it looks at the source data and then matches the data types to what's appropriate in the output warehouse. So on the left-hand side here, you can see the list of all events that have flowed through the system. So that's every Postgres table or every Salesforce object, AdWords report, basically any event that's new into the system. And then I can click on these events and then I can get an idea of what the structure of that event looks like in Snowflake. So here you can see the field name, the column name, and the data type. And then if I click on these various fields, I can also get some information in regards to what kind of values am I seeing pass through these columns. So here's a few examples. And lastly, where is this data being loaded? In this case, it's going to the normalized schema in Snowflake and the employees table. Again, as this is also the part where you would see, let's just say, for an example, if somebody added middle name to the employees table at the source, well, this is where you would see the changes happen in the pipeline. There would be a notification posted. You would see a new field appear on the metadata, and after a few seconds, it would get automatically mapped to the appropriate data type, update the underlying employees table to add that new column, and then basically allow data to just keep flowing through unimpeded. That pretty much covers the mapper side of things. Next up, I'll show you is the code engine. So this is the code engine. And at a high level, you can think of this as a streaming application that lives on your pipeline. This application happens to be a Python 3 environment. And given that it's Python, there's a lot of degrees of flexibility over how you can manage and manipulate your data as it's in transit through our systems. So when you first log into the system, your actual code engine will look like this, which means don't do anything, pass the data through as is, because many use cases, people don't need to transform the data, they just want to load it exactly as it is and then do their transformations after the fact. However, if you want to be a little bit more granular and you want the ability to enrich your data, clean out sensitive fields, hash certain passwords, maybe look things up, that's really where you can utilize the power of our code engine to do all these things. So a quick example here is I can pull a sample from the stream. So I can pull a sample for the normalized departments event that we were just looking at in the mapper. And if I run a test, As you'd expect, there is no changes. The data comes through exactly as it was on the source. However, maybe we want to be a little bit more granular and start modifying the data, let's say, depending on where it came from or maybe where it wants to go. So just before I hit run test again, I'll just run through a few examples here. You can see we've set up a user-defined function to split out events. So that allows you to extract child events from a particular parent event. We have a little function here to discard some data if the login status is failed. In other words, we don't want to record that event because it's not relevant. You can see as well that we imported packages. Here I'm importing GUIP package, and then I'm actually utilizing that function call further down to enrich the data in transit. So we're adding these new fields that didn't exist prior to the event as it's flowing through Alooma. And then last, we have some of the functions to remove null values, just a little bit of cleaning on the data. So earlier on, I showed you that I pulled a sample for the normalized departments event, and I ran the test, and as you expected beforehand, before I repasted back in the code, the data looks exactly as is, as to be expected. However, now that I've reinserted back that code, if I run test a second time, you will see and notice straight away that this dictionary has now turned into a list of dictionaries. So this is an example of us actually taking a single piece of information that came from a single table, and in this case, actually routing the data to two separate tables simultaneously. So this is a real good example of the flexibility of Alooma. It's not just a one-to-one mapping of event and data. You can actually be a little bit more granular and decide where you want to route data dependent on this key, the event type. I should also mention as well that this can be versioned in GitHub and deployed from there. So you can actually have all of this stuff, you know, with all your tracking, all your metrics, with your unit tests, and then when you're ready, you can deploy from GitHub directly into our code engine. So we have some customers today that utilize it like that. If I make some changes on the code on the code engine here, all I have to do is come up here and hit deploy, and that will actually deploy the most recent changes directly on the pipeline. I also have the ability here to be, you know, to make this code engine a little bit more modular. I can actually add in separate files, so I can break up my my logic into separate entities. So it makes processing a little bit easier and makes the programming of it a little bit easier as well. And that covers everything on the code engine side of things, I think. Next up, which is going to be a good segue, is the restream queue. So this loads up. Here we go. So at the high level, what is the restream queue? Well, the restream queue is Alooma's way, or Alooma's catch net for your data. So for any particular reason, if your data is not written to the tables in the warehouse, well, where does it go? Well, it doesn't get dropped or get lost by the system, or it has to be reprocessed all from scratch again. It actually gets pushed into a temporary buffer where it will remain until you explicitly purge the data or fix the issue on the pipeline and restream it back into the warehouse. So why would data not make it to the table? Well, it can be for a variety of reasons. In this case, you can see there's a lot of code engine errors. And this is because we were actually manually raising an exception in the code engine, something that you can actually do for customized notifications. But you can see this was a code engine error. Maybe Snowflake is down. Maybe it was a type conversion error, like I mentioned. Maybe there was an integer field that now is seeing floats come in. All of these would be reasons for why data would not get written to the warehouse. And in that case, it will end up in the restream queue, as I say, until it's explicitly purged or the issue's resolved. And what this restream queue view allows you to do is just inspect all the elements that are inside that queue, so you can see which particular single line events are not being written to the warehouse, and then you can take action to resolve them. So here you can see the input labels. So where is the data coming from? A large part of this is from S3, as you can see. I can hit the event type here, and I can get information in regards to which actual events are caught up in the pipeline. And lastly, the error type. What kind of errors is blocking my pipeline? So right now you can see that the majority of them are from a code engine error, and that was because of the manual exception. And if we remove that and I hit restream, this data, this 1.2 million elements, will be replayed back into the warehouse. So the takeaway you can think of, this is just ensuring that your data is safe. It doesn't get lost. The pipeline doesn't get backed up because we can't write to the warehouse. So we always retain this information, and then once your pipeline has been resolved, the data will be restreamed back in. And last up is Alooma Live. So this is actually a publicly available URL. It's alooma.com/live. And what you're seeing here is actually a live view into the underlying sources that are streaming data into the system. So here you can see that the mobile SDK, MySQL, and Salesforce are all currently replicating data. I can get a little bit of information here in regards to the EPS. I also have a visual breakdown in terms of a bar chart here, colored bar chart for each source. And lastly, I have the options here of doing textual filterings on the stream right now. So for example, I can search for page, and you'll notice that page view comes directly from the mobile SDK itself, which is what is expected. But at a high level, this is a really good visual overview over the data that's flowing into the system. So it lets me see what sources are streaming data and at sort of what bandwidth. And that's pretty much everything on the live side.
Thanks so much, Sean, for the great demo.
Thank you very much.
If you haven't done so already, please send us your questions in the chat panel, and we'll get started with the first question. So Sean, you talked a lot about real-time and streaming. Can you also do batch, or is this just for real-time use cases?
No, it can do both. Alooma is designed to support multiple different types of workloads. So both batch and real-time are supported. And real-time, obviously, in relation to how fast we can actually stream the data from the source. So if the source allows it, we'll continue to pull as fast as possible.
Great. So quick follow-up on that. How fast can Alooma replicate data from Postgres into Snowflake?
That's dependent usually on network and also Postgres versions, but sub 5 minutes usually from the time that the data is written to the bin log to when, or the wall logs in this case, to when it actually lands in Snowflake. Great.
So this webinar was all about Snowflake, but what other data warehouses does Alooma work with?
So Alooma supports all the main cloud data warehouses, so Redshift, BigQuery, obviously Snowflake, and we also have Azure in beta, so that will be coming out soon.
Great. Diving looks like back into the product, what type of alerting is available?
Okay, great. Well, let me just jump in. I'll show you here. So at the dashboard level, we have this list of notifications here that are posted on the right-hand side. And this notification panel lets me post every information about successes, warnings, and failures on the system. All of these as well are available via email. So if I go to the settings here and go to email alerts, you can set up email alerts on regards to these various notifications. Again, you can see errors, warnings, and information. And then you have the option of setting up what your frequency is, whether it's daily or hourly. And lastly, you can decide whether the data will be in digest email form or as it happens. So as the errors and warnings occur, we'll send an email at that point in time. And also be aware that any extra, as I say, any other events that are erroneous and haven't made it through the system, you can also fall back on the restream queue where all the errors are listed per event.
Great. So maybe one last question. Could you go back and explain the use of a staging table?
Of course, no problem. So I'm just navigating back to the mapper here. So you can see, if I scroll over the normalized employees and the little question mark that's beside it, you can see that it says that the event is being loaded into the employees log table in consolidated employees. And so what that means is that we're basically staging data in a table which holds data temporarily before it gets merged into the final table. So this log table will contain all the updates, inserts, and deletes, all those operations that occur on the table. And then periodically, those events are consolidated into a final table, which reflects the actual state of the source table right now.
Great. Well, thank you, everyone. On behalf of Sean and I, we'd like to thank you for joining us today, and we look forward to hosting you on future webinars. Thank you.
Thank you very much.